Hi, this is Rashmi, and welcome to BPS Summer Coding Sampler. Today, Haruna, myself, and Michelle, we are logging in from different locations. So, to hi to everyone, and we are saying hello on the today's meet as well. Give me a quick second. We are going to switch to today's agenda. Okay. Please do let us know if you cannot hear, or also announce yourself on the today's meet as you're joining us live. Thank you. So welcome again to the BPS Summer Coding Sampler. This is session 8. We are exploring dynamic visualization techniques and some softwares, tools associated with that, and how that sort of informs our computing spectrum or computational thinking spectrum. That's sort of the topic of discussion today. So moving on today, again, the agenda for today is going to focus a lot on different types of tools, and we've seen that most data seems many a times meaningless to students. So it's unless it is visualized. So sort of stepping beyond familiar visualizations like bar charts or pie charts, we are going to look at concepts of visualizing data from, say, mapping, which is like maps showing voting patterns, to visualizing networks, to visualizing specific concepts such as functions, objects, variables, iterations. So today we are going to look at a series of tools that allow us to do that. We'll be looking at Sketchpad, which is one of the tools that allows for dynamic visualization. GeoGebra will also be looking at tools that now are widely used for conceptual visualization of mathematical ideas and sort of generalization, conjecturing. So it also goes into the computational thinking spectrum. We'll also look at processing, which is a software, a flexible software sketchbook. It's also a language which focuses a lot on programming concepts and learning basic as well as advanced concepts of coding in the context of programming constructs, visual arts, visual literacy, 2D, 3D modeling, and stuff like that. So we'll look at some of the examples of those. And then, of course, we are going to animate and iterate some of really beautiful Pythagorean trees. And then look at some other examples of how conjecturing or explaining certain concepts can look like visually for students, and how that enhances understanding for students. Lastly, but not the least, sort of focusing on what is dynamic visualization. So, we have 2 more people joining. Hello, Alma, and hello, Vio. Quickly, I just wanted to show you, I've been putting together a toolkit for dynamic visualization tools, and this is going to be part of our conversation for STEM learning series as well, STEAM learning series, which was going on in summer and will continue in fall. Sort of looking at these different platforms and tools that allow you to build these interactively manipulating models, but at the same time, so for example, you can do powerful graphics frameworks, or you can do dynamic interactive time series visualization. So in here we have Google Chart, Google Fusion tables, but a lot of these tools are based off of Java. So you can see that they are platform independent, and hence can work very well across Windows or Mac, and so on and so forth. Obviously, today we are not going to look at a lot of these. Looking at some of these is part of your homework, just sort of going through some of the exemplars. But we are going to look at, where did it go? We are going to look at processing, which is, again, an open source programming language and environment, which allows us to do programming through different models. So you can do it through JavaScript, you can do it through Python. So there is a very different interface that it allows for, which is very unique to this language. And there is a huge community around processing. So we are going to look at those today. So quickly moving on, logistics. If you are joining in, and I'm seeing a couple of people already joined in, please make sure you are logged in onto the today's meet, and we have the link right here and in BPS Learns. So BPS Learns, this is our course right here, and prior to that, you attended, hopefully you attended the Scratch Junior. We are in our 8th session today. The webinar YouTube link is right here. Today's meet link is right here. And then we have our exit tickets and other homeworks that are posted out here. I'm going to add more to this additional resources. So things like, the dynamic visualization toolkit that I'm putting together will be up there as well. So this is part of your Go Beyond activity or exploration activity, wherein you can, explore some of these tools and see how they would fit in with your class. So, and again, making sure we are quoting our sources, which is one of the strategies and very important strategy we follow, especially since we are looking at maybe borrowing some images or even exemplars from some of these websites. Please do know that if you have some time, and we'll talk about this, you're going to have a gap of 2 weeks after this session. And we're seeing that it really would be helpful if you catch up on your participation and assignment and sort of get to the stage where you're comfortable in terms of your assignments and completing all the exit tickets and so on and so forth. So we'll talk about that gap at the end as well, because that's a nice little 2-week break that you get to catch up on stuff. So what is the learning objective for today? These are just broad strokes. We are going to explore multiple representations, and of course, that seeps into the ways of problem solving. We are going to investigate content relationships. So we are going to look at some mathematical content today, so that seamlessly flows into a content area, but is also very specific to programming concepts. We are going to utilize interactive dynamic nature of tools to form and test conjectures. And when I say testing, it is literally proving some of these exemplars, so that you are mathematically or programmatically looking at an object as opposed to what it looks like. So the visual definition versus its mathematical or programmatic definition, and what are the differences between those. We will investigate functions and relationships, and we'll also look at some pre-designed sketches which will help support existing core concepts and enhance the understanding of those concepts. Lastly, we'll definitely look at a few tools to approach the conceptual goals, but there, as I said, there are many tools, and our goal is to gain deeper conceptual understanding as opposed to knowing hundreds of tools. So sort of balancing that at your end also for your students is important. So there are these handouts that I posted on BPS Learns, which gives you a quick tour of some of the tools. What are the text tools? What is a straight edge tool? What is a point tool? And stuff like that. So these are helpful in terms of for students, especially. For you, it may not be the graphics are very they're like comic, but for students, they have proved to have a really good success rate. For the tutorial purposes, if you want to download the trial version of Sketchpad, you can do that. And once you are sure that you'll be implementing it in the classroom, please contact me and I can get you the official licenses for version 5 so that you can implement a full Pro version for Sketchpad. But most of the functionality of Sketchpad is also available in GeoGebra, which we'll talk about in a bit. So you could mix and match some of the activities with GeoGebra, which is a free online tool. So quickly, we use, and most of these activities have been piloted in classrooms, the ones that I'm showing you. So we have some really good feedback from teachers and students, which I would love to share as we go through some of these. So the first activity is, we use this Mural project as an example to sort of get them involved. You can use it at elementary as well as middle school levels. Not so much at high school, depending on what concepts you're introducing. You could modify this into a high school project, especially if you're looking at arc areas or like different types of polygons or dodecagons and stuff like that. So let me quickly switch over to the Sketchpad so that we can. Okay, so okay. So what you're looking at, give me a quick second. I'm going to expand that so that you can see it nicely. Okay. Okay, where did it go? I have so many windows open on my, okay, so here it is. What you're seeing on your screen is the Sketchpad file. A Sketchpad file is always saved as a .gsp. So up top, you will see it says .gsp. And down at the bottom, if you can see it, it shows you two tabs, just like an Excel tab. So this is a great way of organizing any activity in Sketchpad, because it allows you to go between tabs, and you can also have a home space wherein you can link activities within one document, and then you can very easily transition between different documents. So as we look at this specific project, you can see that there are many shapes. So students investigate the properties of shapes, as in not just the areas and the circumferences or perimeters of a circle, but sort of recognizing, the diameter and the radius and how what could be a potential unit circle and that sort of things, which eventually leads to an understanding of, a unit circle leads to a sine wave, and that sort of building up towards it. But this project particularly, you are building up different shapes. And I'm not sure if you can see the toolbar, but let me actually switch, because it's not letting me show you the toolbar. So I'm going to just quickly go to the toolbar so that you can see a view of that. Okay. Oh, looks like it's not going to. Okay, so the toolbar will. Okay, so the toolbar has a few tools in terms of, you can see it up top as well, which is like the file, edit menu, and the display content menu. Hello, Angie. Angie just joined us. So in this case, what we are going to do is, just looking at this mural, we are going to look at an objective of, say, this U-Haul truck over here, which is essentially made up of, say, a quadrilateral. You have multiple quadrilaterals and some circles, if you talk mathematically. And in this case, students are dynamically exploring, the shape, the interior area of it, sort of building it together. They can build shapes which have meanings in terms of the definition of, so like a definition of circle, or if you are building a pentagon, so you have you have your 5 points and how that fills up. Is it a regular one or an irregular one? So you can have multiple conversations regarding the properties of the shapes that you are introducing. Sketchpad also allows you to do some manipulation in terms of constructions. So you're looking at, say for example, one of the favorite activities of teachers is to look at a shape like this, and you see that it is constructed of many different shapes. So in this case, you have I believe 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 arcs, and then there is some sort of a let's count the number of sides. So if students go through this activity of 1, 2, 3, 4, 5, 6, 7, 8, 9 in 10, so sort of a dodecagon, and recognizing that the area of the shape is essentially addition of these arc areas and then the area of that polygon. So recognizing these concepts, and many a times teachers are able to do this in classroom with paper, and then students cut out paper pieces and then they put in together, and that's their cumulative area. So in here they can actually manipulate, build many different shapes, and look at properties of how to build maybe a simple boat like this, but what is the process for it. So recognizing that, or even in this case, what are the shapes, what is the area, what is the circumference. So again, the language objective is also achieved. What I'm going to show you, this is another project that one of the teachers submitted. It's called a mandala project, but they were exploring some symmetry and then again cumulative area. So that was one of the products that they came together. It's not necessarily entirely symmetric, but as you can see, the effort was there, and they used the grid tool in here to enhance that. And we are going to actually do an activity together so you can explore some of the features of Sketchpad. So let me quickly go to another one before we go to the building a parabola animation. So what we are going to do is look at this concept of dynamically visualizing a parabola. So for most, it is, I hope you can see it. Yes. So when you're looking at projects such as these, students are looking at definitions of parabola, and for them it is, a parabola is the locus of points equidistant from a fixed, and you can have objectives like this fixed point, which is called focus, which is a language or a vocabulary objective. But also building some of these is, some of these animations or graphics is pretty intensive, and it also allows them to sort of interact with the software and interact with the inherent programming capability of the software. So in here, just in terms of content connection, they are looking at a focus. They are looking at, this is a fixed distance point from, you can see that the distances are same. You can measure them if you want. And you can see that how the parabola is being formed. You're also hitting the language objectives of focus and directrix. You can build an animation within it, and we are going to build one together just to see how that algorithm of building an animation sort of plays into sort of gaining that understanding of computational thinking or of using a function, but not really, because the purpose here is to be able to build a parabola or draw a parabola according to the geometric definition, as opposed to learning the specifics of that programming. The programming component just comes in because programming becomes the tool that allows you to build this parabola, or the one that we'll be doing. So I'm going to reset that. We are going to look at the example that we are going to build in a minute. So again, language and making sure that it aligns really well with the vocabulary objectives of the lesson is important. So we are going to show the focus and directrix. We have constructed a perpendicular bisector. We are tracing, um, locus of lines, and in this case you can see that the locus of lines is giving you, iteratively giving you, a parabola. And this is a really good example because in real life, without dynamic visualization, it is really impossible to build or draw so many lines and actually see the locus being or getting constructed as a parabola. So this is a unique sort of software experience for students, which really enhances their understanding for the concepts. So I'm going to also sort of emphasize, you can construct a point of tangency. So again, extending it beyond, say, maybe a sixth grader would look at focus and directrix, but then as you go into high schools, points of tangency, and then, what does that mean in terms of the conceptual understanding of parabola. So I moved it. What is the axis of symmetry? So having, again, that aspect of vocabulary as well as the definition of geometric definition or algebraic definition of parabola. This is another one which we very seamlessly move from a geometric definition to an algebraic definition of parabola. And this is a nice little way of explaining your parabolic equation, but then you have these sliders that you construct, which change the value of your A right here. And that changes your parabola, and you can see how it transitions, or how the H changes your parabola in terms of movement around the x-axis, and how does the K changes it around movement around the y-axis. So seeing that and seeing the variation and what the variation means in terms of the mathematical equation is a really rich conversation you can have with the students. I'm going to quickly, this is another one that sort of builds a parabola, and this is another fourth sort of way of looking at parabolas, and it is literally impossible to construct these as you go through traditional methods of visualizing mathematical concepts. And as you see, underlying there is this whole concept of building a parabola, or constructing or designing, which leads you into the aspect of algorithms and process, and what are the steps very much so depends on how good mathematically you're understanding the problem, or in this case the concept, because unless you do, you cannot build a parabola in here. So and then just sort of taking it a little bit further in terms of the programming aspect of it, is this whole connection from the concept, which is a mathematical concept, to the real world. So looking at simple examples would be parabolic mirrors. They are used in cars, and it's sort of a focus of discussion in physics as well. So where do we really place the light source in the car headlights to get the optimum focus of light on the street as we're driving at night, say? So if my focus of light or light source or my bulb is positioned here, and I emit light, it is going to reflect in many different directions, which essentially means that I'm not going to get that focused light on the street, and I'll not be able to see the road that I'm traveling on. So not a really good design. So here is where the definition of a parabola comes into play. So sort of looking at what is the focus, and we've talked about it a little bit, and what is the directrix, and then sort of recognizing how we move that light source to focus and directrix, and then then when you emit light, how that mathematical definition really allows you to build an application, or in this case a headlight, that really does what it's supposed to do, which is focusing the light on the street. So seeing some of these exemplars is a really good way for students to connect it back to something that they know or something that they have probably built. And one thing for us, and we are not going to build this animation because it takes for literally a couple of hours to do that, but I wanted to show you how this animation is actually built. So I'm going to show you all the hidden objects. So it's a very intense sort of graphical programming that one has to do in order to achieve that effect. It's very repetitive, so there is a lot of iteration involved in this, but sort of seeing the scope of programming that goes into something which looks simple at, especially when you're looking at the application. So I'm going to stop that and hide objects. So that again gives you this whole, application. And then what we are going to build is something similar to this. So let's get to it. I'm going to open up right in here. I'm going to open up a new sketch. So instead of new sketch, I'm going to go in and just add a page which says parabola animation. So I do that, and as I was adding it, you could see it at the bottom that I have a new tab, and I'm going to add some text saying parabola animation, which is locus of lines. So you can always dress it up in different fonts and different ways. So before we sort of go into the parabola animation, I wanted to show you the handout that we'll be using. And this is part of your homework assignment as well. That's why I wanted you to see. Okay. So you have, I apologize. Right in here, what I've done is I've compiled, I hope you can see it. Yes. So what I've compiled is literally an algorithm for building this animation. And it's a step-by-step algorithm. My recommendation is sort of let students work with the tools before they sort of get into this. So like a mural activity where they are having fun and building something, so they get used to the interface. And then they get into this. It's pretty simple, and you will realize it as you go through it with me today. And in addition to that handout, I'm also providing you with some example codes that we'll be using for our processing examples. For homework, I'm not asking you to do these, but my recommendation is to go beyond, try it out, download processing, play with it so that you sort of get, and these are very simple examples, but it really gives you a wonderful idea about how that works. So quickly going back to our animation, I'm going to the blank page, which is what we created. Okay. Did you see the parabola variation? Yes. So I hope you can see this. And I'm going back to my, yes. So that's my lesson. And the first step in that lesson is to call the page parabola animation, which I did. So as you can see, I have it right here stating at the bottom that it says parabola animation. Now I'm going to draw a line. And it's very important in Geometers Sketchpad or in any sort of programming environment. It's important to understand the definition of the objects that you're you're drawing more so because in this case you have a mathematical definition. So you could choose a ray, you could choose a segment, but what we want is a line. And mathematically, line goes infinite in both directions. So we're going to press shift, and I apologize. We are going to press shift and we are going to draw a line. In this case, just to make it pretty, I had used I apologize. I'm going to make this solid. So I go to display and I say point style thick, and I do not want it, I want it solid. Okay, so that's my line, and I'm going to label the points. So my point is going to be A. You could label the points A and, okay, we could label the points B. So A and B, or you could go vice versa, and that's your line AB. Now I'm going to draw a point C on line AB. So when I say draw point C on line AB, I'm looking for an intersection, and that intersection, I'm drawing the point tool. I go close to the line, and then when I intersect with line, the line turns red. So I place a point right on it, and every time you place an object, you label it. So I'm going to take my labeling tool and I'm just going to label it. So that's my point C. Just to make sure that my point C is actually on line AB, I'm going to make sure that it moves properly on line AB. Then it asks me to place another point D above line AB. So I can place it somewhere here. And that is my point D. So I got that. Then I'm asking you to draw a segment for C and D. So deselect everything, and then you do C and D. You select both of them, and then you go to your construct menu and you say draw segment AB. I drew segment AB. Then I'm asking you to construct a midpoint on segment AB. So I'm going to choose segment AB, and I'm going to go construct a midpoint. That's the option that I get. You could even right click on it and you get those options. Now this is my midpoint, which is E. Now I'm asking you to choose the midpoint E and segment CD and go to construct and draw a perpendicular line through point E. So in order to draw a perpendicular line, you need a line or a segment that it's going to be perpendicular to. And by definition, you need a point wherein the perpendicular line will be constructed. So this is where the part of defining that object or having an understanding of mathematical understanding behind that object comes into play. So I chose both the objects or definitions that are needed in order for me to build my perpendicular line. So I built my perpendicular line, and I'm going to make that perpendicular line because it's selected. I'm going to make it maybe hairline, and I'm going to make it say dashed. So I can see it nicely, and I'm also going to change the color of it. So I could add say green. Green, red. Yeah, the toolbar. I'm going to try to. I try to combine both the images, and I am not able to show you, but it's on the side, and I'll show you a quick information about the toolbar so that you can see how it is positioned. But it's a really simple 5. Actually, you know what? Let me try and see if I can still. Give me 5 minutes. We'll finish this animation, and then I'm going to show you exclusively how that portion looks. So we built the perpendicular line, and we are going to make sure we opt for trace perpendicular line so that we can see when the perpendicular line moves, we can see it. Otherwise, the visibility of it goes away. And you can see that we are actually building a locus of lines, and we can build the the whole parabola with this. But now I want to also add a little bit of animation to this. So I'm going to go Command Shift E on Mac, or there is also a PC command. And that takes care of all, or erases all the traces. And now what I want to do is essentially not really keep doing this, which is moving point C along or bidirectionally along AB. Again, that whole algorithmic thinking, because I am seeing what I need to do and then I'm going to code it in. So how do I do that? I'm going to choose point C, and I'm going to go into, I'm going to go and say action button, and there is an action button for animation. And I've put in those, and it shows you, I hope you can see this. It gives you an option of point C bidirectionally along line A and B. So I could choose that, and I say okay, which means I have animated my point C to go bidirectionally along line AB, which is exactly what I wanted. So in Sketchpad, there is also this little tool where it becomes this horizontal arrow. It's very tricky to grab hold of any object unless it becomes this tiny horizontal arrow. After that, you can grab it and move it around. So I said animate the point, but I also want to see if it's doing what I'm asking it to do. So I click on it, and it will go around the line with slow speed because I chose slow speed. I could go really fast. And based on my line property, which was dotted or dashed, it's giving me that animation and a solid locus of line parabola. The only way I can stop this animation, it will go on until the software crashes, or it will go on until you press the animate point again. So it stops the animation. I'm going to clean it off, and you have your animation right in here. What we are going to do, I'm actually going to attach a quick toolkit about this toolbox. So give me a quick second. I'm going to switch over to our presentation so that you can see. Okay. So, okay. So one of the things I wanted to show you was the geometer. I'm going in here, and I can literally show you geometer sketchpad toolbar. And it gives you a quick view of the tools and the toolbar and the custom tools. So in here, what we have, this is usually in Windows, it can connect with your main window. So you might be able to just tag it to your main window. But in here, and I'm going to zoom it in so you can see it, you have all the menus that come up front, right up top, and then you have these tools. So let me zoom it in, and I can show you what it looks like. So, right. So in here, if you see, the first one is your arrow tool, which allows you to literally choose an object. The second one is a point tool, so you can place points the way I did with my you can take a point to a line and you can place it on the line, and you can see whether it's intersecting or not. Or in order to define a polygon, you would need 4 points. Then there is a circle tool, which will draw circles. There is the fourth tool is your line, segment, or ray. So it gives you this little arrow right here, gives you the option of choosing one of the three. Then comes your polygon tool. So you can choose the number of vertices, and based on that, your polygon will be drawn. A is your text tool. And then you have some annotation or sort of commenting that you could do. But mostly the top 5 tools are what you use. It's very basic in terms of the tools, because the focus is on what you do with these basic tools to build a really robust visualization, mathematical visualization. So the tools will adhere, like a line or a segment will adhere to the properties, but those are the basic building blocks in any geometric or algebraic construction. So that's what you get. And you have a quick little tutorial about what are the different menus up top. So in terms of file or edit or display, construct, what are some of the menus that are available. So I'm going to attach that into our BPS Learns as well. So moving on, we did a quick parabola. Then we are going to look at, that parabola had this whole concept of, taking a step of drawing a line and then iterating it over and over again, which is what the locus is. And in a general programming construct, it would be a loop, but in this visual dynamic space, you're seeing it visually what that looping looks like. Iteration also allows algorithm to be simplified by stating certain steps will repeat until told otherwise. And we just sort of did that in building our parabola. But we are going to also look at another example, which is fractals and Pythagoras, but in a more iterative pattern. So let's quickly go there. Okay. Oh. Parabola. Okay. Okay. So it should open up. Okay. So let me close that. Yes. So what I'm showing you here is a nice little fractal tree. And in that handout that I shared with you, you also have a handout at the bottom which allows you to build this fractal tree. And it essentially focuses on display all hidden object. So it focuses on the basic construction of Pythagoras theorem. And then, it is iterated over and over and over again many, many times. So here is where, a programmatic construct of iteration comes into play, because it really allows you to see or visually understand what an iteration looks like, and we can change that. This is a little bit of a complex construction. So I would, that's why it's a go beyond activity. But if you want to try it, please do so. Or you can also connect with us for the STEAM webinar series, and we have scaffolded activities that lead up to this as well. Hide objects. So I also wanted to quickly show you a couple more, while we are at it, a couple more sort of algorithms, so which are using iterations. So fractals are in here, which allow you to, you can see that you can add more. Just a second. Okay. Okay. I'm going to, yeah. So it gives me a calculation in terms of how to change or iterate it. So today my, it is, okay. So I think the iterative cycle is not working, but let me try it again. Okay, so it did now. I chose a function, so so I'm going to choose the arc, and what it does, it allows me to sort of build this golden spiral, which is again an iteration, because you can see that it's the same thing repeating over and over again. So the algorithm is repeating over and over again. And you know, this whole concept is very difficult to understand sometimes, iterations or recursions, but with fractals as an example, and with visual programming languages such as these, or processing, it becomes a concept that students can relate to. So there are many different fractals that we will be building in the STEM webinar series, or you can join us for the STEM webinar series sessions, or you can watch them on YouTube and try to follow through as well. But this is a great way of introducing some of these programming concepts to the students. So I'm going to go back to my beautiful, and I'm just being aware of the time. And I'm going to stop here so that I have. Then moving on, the next part, I wanted to take you to, processing, so that you can see some examples of that. So let's look at this exploring functions. I would show you at the end if we have some time, but sort of let's move on to processing so that we can see some of the examples of processing. Now, processing is a flexible software sketchbook, and it has a language for learning basic as well as advanced computational concepts. So the processing development environment, which is called PDE, it is very easy to write processing programs. They are called sketches. And there is a sketchbook, which is a really nice way of appealing to the visual art component of it. But and they are collected in the sketchbook. So I'm going to go to the processing. But before that, let me show you what that environment. You can download processing right from here, and I have linked it on the on our BPS Learns. If you have any problems sort of downloading or implementing it, or if you're having version issues, please let me know. Up top, you can see that there is a P5.js, which is the JavaScript version, Python version, and so on and so forth. So you can, the processing is very adaptable to many different languages. The IDE includes a text editor and a compiler and a display window. Very simple, very not intensive for the computer, so it's a great language to adapt into your classroom. And I'm quickly going to go to processing, which is a very simple window. Okay, so this is what your processing console looks like. And in this case, we are going to look at very basic components. And I love the simplicity of this software because it doesn't give you too many bells and whistles. It gives you what you need in order to learn the concepts of programming. With processing, you can do, regular programming, understand basic concepts of coding, but you can also use visual literacy with it. You can do 2D models, 3D models, and it exports itself into a 2D, 3D model as well as a PDF. So you can see the outputs can be exported in many different ways. So what you have up here is a simple play button and a stop button that allows you to run your program. You have your, you can play it in different modes, as I mentioned. You have a Java mode or a Python mode, and we'll explore a little bit more of this during the JavaScript as well. down here is your console, and if you have errors when you write your program, you will see errors right here. It's as simple as that. And this gives you, once you write your code in here, it will give, when you run it, it'll give you another compilation window wherein you can see what your code does. So let's look at the first coding example. So I'm just going to build a simple ellipse or some sort of a shape. So I'm going to, let me just type it in because otherwise it's going to take me a lot of time to put these things in. So I'm right here, and I'm going to go back in there. Where did my environment go? Okay, so I put in, I took a function called ellipse, I put in some parameters for it, and I'm going to run it. When I run this, I want to see if you can see the output, because if you cannot, then I have to switch the window for you. Can someone give me feedback if you can see the output on at your end? No, I don't think so. Okay. Let's see. I'm going to actually try to switch between windows so that you can see the output. So for our ellipse, we just programmed an ellipse, and I'm going to go in and try to choose that window so you can see the output. The output is essentially a circle. In this case, it is an ellipse, but visually it's very hard to see because the dimensions are very small, and I can increase the dimensions. But what I'm going to do now, since you know, we looked at the very first instruction, and I didn't want to put in hello world, I'm going to go back to our programming window, and I'm going to put in the second program, which is right here. It allowed me, the first one allowed me to draw an ellipse. And now the second one is, let's see what it allows me to do. So I'm going to erase this, and I'm going to paste this. My program, you can type it in, making sure that you're following the constructs and the syntax of the program. It's very important. So it's very simple. This syntax is not punishing. It's not as rigorous as Java, but you still have to make sure you open your curly braces and you close your curly braces, and then you have your semicolons and so on and so forth. So let's see what this does. I'm going to quickly look at the example in my other window. Okay, so I'm going to run it. I'm going to stop. I'm going to run it and see if it gives me that window. Good. And I hope you can see it first. So I'm going to go in and show you that window, so you can see it. Okay, so what I did is I drew this, and as I move my mouse over this window, you can see that there is this beautiful animation that it creates. It's essentially that ellipse that we used, and it is repeatedly drawing it into that program. And it's a beautiful, visually stimulating graphic which uses just a simple if-else and an input for that ellipse, which is your mouse X and mouse Y, if you're looking at the code. So this is a really good example of, sort of introducing it at the beginning. You have a function, then you are introducing a small, if-else statement, and looking at sort of the implementation of that. So in this case, couple of things to keep in mind is the program creates a window. So let's go back to the program so that we can quickly go through the code. Here you go. So So as you look at this code, you are going to see that it sets up, it creates a window of 480 pixels to 120. So you defined that window, which was sort of this rectangular window. And then it's obviously you saw that it started drawing the circles. So you have this void draw, which is you have a draw function which is inherently built into processing. We have if mouse press, which is when you press it, you fill up with white color, and then you else fill up with 255, which is also another color. In this case, it's black. And you're taking input into your ellipse as mouse X, mouse Y, which is your input from your mouse. So it's a really simple example and sort of gets you going with the students. Of course, if they've had Scratch before, they've worked with some if-else, if they've not looked at a text-based language before, this is a simple enough language without too much of constructs or build up around it. We're going to do one more example because I know we are nearing our end time. Excuse me. So I just quickly wanted to get the we are going to try to, this was another really simple program that allows you to a draw function for many times, and it allows you to draw a little bit of animation. So I'm going to stop it. I'm going to run it. And then, oh, you cannot see the window. I wish you could run it at your end. Because what it allows you to do is build the smallest, simplest possible animation, one that cannot stop unless you stop it. So as you can see, those are really the line, they're drawing the lines in this program, and literally called many times per second. So that's up top in the code, you see that I have put in a lot of comments for the function draw, because it's literally drawing those lines many times over in per second. And it's a useful animating sort of object, and then you're making sure you're opening and closing your curly braces. The background in here is what defines the color. If you change these values, it's going to change the color of your background. And then if you see the succinctness of that code and the software, we are optimizing the use of software. You could look at the code as line, and you have 4 inputs that are coming into the function, which are drawing the lines in here. So just keeping in mind, simpler programs, and we are going to have a series of processing webinars, which will have literally basic, we'll start with basic functions of how to draw a line, and then how to move the line, then how to draw a point, to building a simple animation and onwards. So if you are interested in experimenting with this language, please join us for those webinar sessions. We'll probably plan for 4 or 5 of those, which will be a really cool visual design exercise to undertake with programming. Without further ado, I'm going to quickly switch to the next activity. There is one more program that I did not go through, but we have, we are sort of struggling with time, so I'm going to, give me a quick second. So you have right in here, you have the examples. This one is also really cool. It takes the same line element, but it has fixed values, and it's going to randomize it. And how does that look onto your screen? And it's going to look, and what are some of the differences you see between the 2 programs? That's sort of a really good discussion to have. My recommendation is to try these programs out in processing. They're very simple programs. Play with them, break them, see how the editor looks like to you when you break a program. What are the errors you're getting? What are possible syntax errors you will do? So that would be a good way of looking at it. What you're seeing here is that handout for Pythagorean theorem that we talked about. And So feel free. I wanted to show you some of these activities as well, but we'll sort of take some time and join us for the processing sessions. These were a couple other ones which use some iterative principles to draw some of these objects. Again, we'll be covering these in the webinar sessions. So GeoGebra, without further ado, I'm not going to take too much time to explain this one because it's very similar to Sketchpad, but it allows you to see the whole structure. And what we have in here is, you know, a very simple, again, a very simple interface. You can just press new, you can find some materials here, and new gets you to a new GeoGebra interface, and you can choose it for algebra, geometry, spreadsheet, 3D graphics, or probability sort of setup. I'm just going to go into geometry because it gives me a quick view of the tools in here. And right up top, you can see that, you know, you have the similar tools that we saw in Sketchpad. You have your arrow tool, your point tool, which gives you an option of point on object, attach, detach point, intersect a point, so on and so forth. Line gives you a line, a segment, array, vector. GeoGebra gives you a little bit more in terms of, you know, the vectors aspect of it, but you know, in Sketchpad you'll have to define them in order to build them. Again, the next menu is giving you draw perpendicular line and so on and so forth. Then you have your polygons, regular, rigid, circles, your ellipses, angles, reflections or transformations, so on and so forth. So what I'm going to do is quickly show you how maybe we can do one activity. So what I'm doing is literally building a triangle right here. And then I am going to build, I want to build a centroid, which is the intersection of medians. Now, what are medians? Medians are segments joining the vertex of a triangle to the midpoint of the opposite segment. So I'm going to, I need a midpoint on the opposite segment. So I'm going to go to the midpoint. I go here and it's going to place a midpoint. Because it understands mathematically that I want to place a midpoint on these segments. So I did that. Always label them. I'm not labeling them right now, but always label your objects. And then I'm going to use segments. I'm going to draw a segment from here to the midpoint, 1. Then I'm going to draw from the vertex to the midpoint, and then I'm going to draw from the vertex to the midpoint. And right here is a test of the mathematical aspect of this triangle. So as I move this triangle or do the drag test, mathematical drag test, you see that the medians is staying put, and so there seems to be a question. Haruna, I do not understand when you said, can you explain what the 4 parameters are? Could you clarify that question? So while she does that, I'm going to ask you to play with your object, because you're going to try to do one of these activities in your classroom. Maybe building a same median centroid would be great. But it's important that they pass the drag test like this, and then the point that's right in the center of this is your centroid, which is the intersection of the 3 medians. So you got that. What I'm going to show you is how to build a simple square, but with a mathematical definition. So that goes back to your algorithm. And what I did here is actually a screencast of that. So let's quickly see. We're using the segment of 2 lines. And so I built a segment AB. Then I am drawing a perpendicular line to my segment AB through point B. I am going to construct a circle from B, which intersects at point A, and then I'm going to do the intersection between the perpendicular line and circle as point C. I go in and construct another perpendicular at point A and do the same thing with the circle. Build a circle which intersects at point B, and then just construct points at the intersection. Use the polygon tool to, I have 4 vertices, so I'm going to build a square. We are building a square which will have the same definition in terms of, you know, the angles, which are 90 degrees, and you have the you know, the option of choosing the objects and then hiding them, which will be, you know, the version of sort of not seeing the construction, but you could keep them active for students, and then that will be your you know, drag test for your square. So you can see that as I move my square around the vertices, it is keeping the properties of that square intact. And again, from the perspective of an algorithm, this is very important because you are building a square from scratch, but it has an algorithmic significance. So for homework, you will be building a square for one of the activities instead of the Desmos activities, because I wanted you to go through the GeoGebra interface. So last but not the least, I'm going to take 5 minutes to show you what Desmos is. And we have an elaborate webinar series on Desmos and other tools that we have mentioned here in the STEAM session. So please join in. They're available to you on YouTube as well, the DLT YouTube channel. But if you want to know more, join us for those sessions. So I'm going to quickly log in. If I go to Teacher Desmos, you can see that there are many exemplars. These are visualizations of mathematical concepts, or even some of them are creative artistic concepts which build. You do not really have to have a student account section built in right now. You could explore, but you can use your Google account to log in and make an account in Desmos, and then you get activities such as this. I'm just going to go into Match My Parabola, and there are thousands of activities in here which allow you to browse through many different you know, screens or examples that students are looking at. Very similar to what we did in terms of you know, Sketchpad, but in Sketchpad you have the capability of building an application. You have the capability of JavaScript integrated in it. So that allows you to do a little bit more programming. What Desmos allows you to do is dynamic visualization and conjecturing and proving those conjectures. So it aligns with computational thinking and content matter, but it does not allow you to build a specific application. So looking at our recommendation is to play with some of these applications or applets to see how they would fit in, if they would fit in into your classroom if you are teaching mathematics or science. And there are some really great directly connected to the mathematics and science standards applications. So my recommendation is sort of looking through them, looking through the STEAM sessions. I'm going to go back to my, they have featured activities that you can look at, or you can even search for an activity. So if I search by linear, I end up getting so many activities which will allow me to look at linear equalities or graphing, or understanding the concepts and proving certain concepts. So that was your Desmos. I was hoping that you would be able to do one of the Desmos activities, but we don't have enough time, which is why we are going to, as for homework, we are going to build the GeoGebra square. And as we look through a lot of these curriculums or activities, we are constantly keeping in mind the standards for computer science. I refer to CSTA a lot because all nationally recognized curriculums align with CSTA K-12 standards, and the strands of computational thinking and computing practice and programming. Of course, you have mathematics content and science standards. There are new science standards coming up, but we have MADL-CS standards, which very well align with the CSTA standards and the 4 strands of computing and society, digital tools and collaboration, computing system and computational thinking. So a lot of these activities do go towards, modeling, simulation, focusing on algorithm development, focusing on what an algorithm looks like, and what is the definition for it in terms of the programming constructs, and then bringing that into reality with either processing, Sketchpad, or any other tool, so that it can do what you are expecting that algorithm to do. So the end result is achievable. And then, I think the collaboration aspect of it is very important. So recognizing that a lot of these tools are now offering you opportunities to share your sketches or to share your programming models with others, so that not only can they provide feedback, maybe they can improve upon the model. So sort of thinking about these curriculum frameworks and implementing the learning objectives as you go through the activities. We've talked about computational thinking. It's much more than being able to use tools. Of course, it's a logical way of approaching problems and solving problems, and having a map and a process, which is essentially going to benefit students in so many different ways. Last but not the least, I'm going to change the third activity, which is complete the Desmos activity, to the GeoGebra activity of building that square, a perfect square in mathematical sense. So you have your exit ticket right in here. And I'm also right here. You have your penny circle activity, which is what I was going to ask you to do, but I will change that to GeoGebra. And then, ideally, please go through some of these visualizing tools. We will be doing a webinar series on these and a few more in detail, so that you can build up to, a tool like processing or understanding text. But the objective is to be able to look at data and to be able to visualize it and connect it to your computational thinking. Lastly, we have the fractal, Pythagorean fractal. If you want to take it on and try it, you could do that in Sketchpad, or you could build it in GeoGebra. So it's up to you. You can definitely connect with us, email me. We can talk about the process. We have a GeoGebra and Sketchpad model built in, so we can give you that as well to showcase for your students. Back engineer recommendations. One of my favorite ones is always back engineer programming examples to enhance understanding. So what is it doing? What is it? What will happen if I change random number from 100 to 1? So one of the questions that was asked on this was, what were the parameters on Ellipse? So sometimes even trying to change the parameters will give you an output which either will be an error, or it will sort of give you an understanding of what that parameter is doing. So for example, when you are drawing and you have these 4 values in there, what are they doing? Are you getting an orange color? You might get a black color or a green color. So sort of reverse engineering a programming example would really allow you to see what's happening with it. Test as you build, it is very important. So step by step, in the processing examples, you had 3 steps. So it's really very small structure. It's a text-based language. But my recommendation is, if you are thirsty for more processing or other text-based languages, please join us for a more detailed session. And we would love to sort of go through each step with you as well, as building different models. And again, collaborate, share good resources as you uncover them. What's working for you might be very useful for others, will be very useful for others, and explore beyond what's covered in the webinars. Lastly, we've been saying this many, many times. There is a Learn, Teach, Lead conference coming up on Wednesday, August 10th at Boston Latin School. Go to the website. There's more details over there. But it's going to be a really great session, so led by teachers. So it would be a really great resource sharing session as well. And next session, we have a 2 weeks break. So please use this time to take a little bit of break and catch up on your assignments. Next session, I believe, is MIT App Inventor, which will be on August 15th. But it is absolutely, 3 to 4 on Monday, the 2 weeks. Use them, complete your assignments, and join us. And lastly, there was a question about Ellipse that I believe Haruna had. So I'm going to post what were the, I don't want to keep everyone here, but I'll try to answer that specific question into BPS Learns forum as well, so that everyone can have access to it. Other than that, is there any other question, Michelle? Okay. Okay, so thank you, Angie, and Michelle, thank you so much. And we look forward to seeing you for the next session. Thank you.